we want to prove that the third root of 2 is irrational. We're going to apply the method of contradiction. In this method, assume that the statement to be proved is false. It means that suppose that the negation of the statement is true, show that this supposition leads logically to a contradiction or something that we know is false. Conclude that the statement to be proved is true. So let's apply this method here. Proof by contradiction, suppose not, and this number is a rational number. Since it's a rational number, by definition of a rational number, it is equal to a fraction. For some integers, a and b, b is not 0. This is super important. The red arrow is referring to a super important assumption. We assume this fraction is in reduced form and there is no common factor between a and b other than 1. Well, let's do a little bit of algebra. Raise both sides to the third power. You get 2 equals to a cubed divided by b cubed. Do the cross multiplication, a cubed becomes 2b cubed. So it means that a cubed is equal to 2 times an integer. So it means that a cubed is even. Since a cubed is even, a is even. So take a look at this arrow here. A is even. It means that a is a multiple of 2. Since a is a multiple of 2, a is 2 times k. So if you raise both sides to the third power, a cubed becomes 8k cubed. But at the same time, a cubed is equal to 2b cubed. Write it on the right-hand side. Simplify this equality. 4k cubed becomes b cubed. So b cubed is equal to 2 times an integer. What's the meaning of that? It means that b cubed is even, and then b is even. The contradiction is because of these two. A is even, b is even. It means that they have common factor 2, which is contradiction with the assumption that there is no common factor between a and b. So since we got to a contradiction, it means that this statement is false, so its negation is true.